It's a privilege and welcome again to our next clips as we continue with our elementary set theory, subtopics in elementary set theory. Today we're going to talk about set operations. Set operations. Now, I just want to briefly tell us that set operation is also a very important topic in mathematics or in set theory, because especially when it comes to combining when it comes to bringing together two sets, or bringing a relation, initiating or setting a relation between two or more sets is very, very important. Now, in that, I am also telling you that set operation is also similar to the mathematical idea of number manipulation. A mathematical idea of number manipulation, where we combine or sometimes we subtract numbers. And that and set operations, these are also very similar. Now, in set operations, I can say we have four main kinds of set operation. One is the union of sets, the other one is the intersection of sets, and we have the difference of sets and the complement of sets. Four main kinds of set operation. But for the course of today's class, we're going to look at the union and the intersection of sets. First of all, the union of sets. Now, how do we mean by the union of sets? Union of sets, the idea is just a collection of elements from various sets that are into play or into consideration to form a set. The union of a set is a new set where elements from other subsets are collected to form that new set. Example, let's consider some examples. Let's say we have a set D where its elements are 1, 5, 7, A, and C. Let's say we have another set, say B, where the elements there are, say, 2, 4, 6, B, and B. Let's say we consider another set, let's say set E, where that's the elements in set E are, let's say, A, B, C, and D. Now let's consider these two sets. Now the union of two sets, say two sets, is a collection of the elements that are in the set without repetition. A collection of elements in the set without repetition. Without repetition. So now let's look at these two sets. Let's look at this the union of D and E. It's also my pleasure to inform us that there is a symbol we use in denoting the union, and it goes this way. The union, we use this symbol to represent the union of sets. So if we are interested in the union of two sets, say D and B, we are going to write the union of D union B. This is how it's written, D union B. And that will form a new set, a new collection, a combination of the elements here and the elements here without repetition. Now, what are the elements here? We have 1, 5, 7, A, and C. I have told us that the order in which the elements are arranged does not matter. So we can arrange them alphabetically or just anyhow. So in this case, let's list these ones first. We have 1, we have 5, we have 7, we have 8, A, we have C, and when it comes to this one, we have 2 here, and 2 is not in this one, so D is, or 2 is also distinct. Now we have 4 here, 4 is not also here because we said there is no select and repetition. 6 is not also here, so 4, 6. B is not also here, so with B, so we have 4, 6, and B. So you can see that this set here is a combination of D and B, which means the union of 2 sets. So we are saying that the union of 2 sets is a different set that contains all the elements of the individual set. And from our previous class, you can see that this one it contains all the elements of either D and A. So in a way, we can say D is a proper subset and B is also a proper subset of the union of D and B. So this is how we do it. Now, if we are to consider, say, another set, D union E. If we are to consider another set, say D union E. D union E. This will be a collection where we have all the elements D here. Say, I say the order in which they are arranged does not matter, so we can write 1, 5, 7, A, C. Now, when it comes to E, you can see that A is here. So we don't, and we have collected this, so we don't need to write it. B is here, but B is not contained in this one, so we can include B here, B here. You can see that C is here, and C is also here. And we said there is no need for repetition. So we don't need to write it because we have taken it already. And the last one is D. D. So you can see that we have successfully combined this and this. So it's a combination. And in mathematical idea, you can see that this looks like bringing together addition, the plus. So we are saying that the concept, the mathematical concept or idea of manipulation of numbers is also similar to that of set operation, especially in this case where we're talking about the union. It is similar to bringing together, combining, adding two things. So this is it. So you can see that the union of D and E is a new set, a collection of all the elements in the other subset. And as we have stated earlier, you can also see that D and E, they are all proper subsets of these ones. Because all the elements, proper subset, because all the elements of D are contained, and there are also some elements in the universal set that are also contained in D. And in like manner, all the elements of E are also contained here, and there are also some elements that are in the universal that are not in D. So in a way, they are all proper subsets of the union of these two sets. Now, having known that, we can also by determining the cardinality of the set. And the cardinality of the union of two sets, the cardinality of the union. And we have said the cardinality, we can symbolize it as this. This union, say B. And we said this cardinality is simply knowing the total number of elements that are in that set. So this new set that we have, the union of D and B, is this one. So it's just to know the size, the number of elements in that set. So we can just go straight away by just counting 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. D union B is it contains 9 elements. 9 elements. And you can see that that is true. Now, let's also consider another set. The other set, say, D union E. D union E is another set, where this one we said we have 9 elements, while the other one we have 1, 2, 3, 4, 5, 6, 7. 7 elements in it. But I'm here to tell us that we can also, there is a mathematical formula, a relation that we can use in calculating this, other than just counting. And this we have as if we are to determine the cardinality of the union of two sets, say D union B. This we can write as taking the cardinality of D first plus taking the cardinality of B, then subtract their intersection. Subtract their intersection. Subtract their intersection. Now, if you use this formula, you will still arrive at this. Now, let's try to see if what we are looking at is true. Then, if we are to determine just the cardinality of D, the answer is the cardinality of D is 1, 2, 3, 4, 5. You can see that we have 5 here for D. The cardinality of B is 1, 2, 3, 4. Is 4. Now, their intersection, before we get to that point, we say intersection, because we have talked about it before, is an element that is common between the two sets. An element that is common between the two sets. Now, between D and B, is there any element that is common? You can see that all of them are they are all distinct elements. In a way, we can say they are disjoint sets. They don't have anything in common. If you look at them, so you can say their intersection D intersection B is 0. It's a 5. It's a null set. We don't have anything in it. So if we put all that into this formula that we have, you are going to have, in this place here now, we are going to have 5 plus, in this case here, we are going to have 4 minus, their intersection is 0, is 5, there is nothing. So you say 0. So this plus this gives you 9. And that is the answer. And you can see that it corresponds to this. In like manner, we can also go ahead using similar formula to determine the cardinality of D union E. For that of D union E, we are going to have D union E. This we have the separate individual cardinalities, bringing the individual cardinalities together minus the intersection, which is D intersection E. So from what we did, we already have that this one is the cardinality of D is 5. For that of E, we don't know it yet, so we say the cardinality of E is what? You can come here to count 1, 2, 3, 4. You can see that the cardinality of E is also 4. Is also 4. So in this place, the cardinality of E is 4. Then we say minus their intersection. Do they have anything in common? Let's look at their intersection. D intersection E. Do they have anything in common? D and E. If you look at it, we have A here, we have A here. So 1, we have C here, we have C here. So they have 2 elements in common. Their intersection is 2. So we now have that their intersection here is 2. So you say minus 2. So as we have done before, this plus this gives you 9 minus 2, which gives you 7. So you can see that it's also the same thing as we just counted. So either you can use this formula to also determine the cardinality of the union of 2 sets. Now this you can also do in the case of 3. This you can also do in the case of 3 sets. This you can also do in the case of 3 sets. Now, how do we do that? It's also straight away. Now, if we are to look for the union of D, B, and E, say the union D union B union E is what? Is a different set, it's a collection where we are to combine all the individual elements from the various sets. But note that repetition is not allowed. So in this case, let's go by taking that of D, and we have 1, we have 5, we have 7, we have A, we have C. Now we have successfully taken these ones. Now let's also come here to include this. 2 is here, 4 is here, 6 is here, and B is here, which are also distinct. So we have 2, 4, 6, and B, which are distinct. Because the union is a collection of all the elements from the various sets. Now lastly, that of E. Now E, you can see that but A has been collected already from that of D. B has also been collected from, because B is also contained in the set B. Now C is also taken from the first collection. The only thing that has not been taken is just that of D. So we now write D. So this is a collection of all the sets. So in other words, we are saying here that we can also consider the union of more than two sets, and these are the elements. And if you can study them carefully, you can also see that these individual sets are subsets of their union, because they are all contained in this, and this serves as a superset to the other sets. Now, in like manner as we did in the case of two sets, we can also determine the cardinality of these three sets. So you say the cardinality of D union B union E, the cardinality of these sets. Now, as we know, the cardinality is simply the size of the set. So the size of this set here is, we can just go straight away by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that the elements there in the union of the three sets is 10. The cardinality is 10. We have it as 10. The cardinality is 10. Now, but you can also use a formula as we did in the case of the two sets. We can also use a formula as we did in the case of the two sets, where we have a formula saying take their individual cardinalities, then minus their intersections, D intersection B minus D intersection E minus E intersection B, then lastly plus all their intersections, and you have D intersection B intersection E. Now let's consider this, if what we have as 10 will also appear in this case. Now there are individual cases, we have done that before. For that of the cardinality of D, we have it to be 5. For that of B, we have it to be 4. For that of E, we also have it to be 4. Now, the cardinality of the intersection of D and E. The cardinality of the intersection of D and E. The cardinality of the intersection of D and E. Let's consider that quickly. Now, D intersection B. The cardinality is, what do they have in common, D and B? You can see that they don't have anything in common. They are disjoint sets. So the set is a phi, it's a null set. Then D intersection E. The cardinality of D intersection E. D intersection E. What do they have in common? You can see that they have A here, they have CC in common. So they have 2. The cardinality here is 2. Their intersection is a set and the cardinality is 2. Now for the last one we have E intersection B. And we have that set to be E intersection B. Do they have anything in common? Yes, they have B here. All the other ones are alphabets here, whereas the other one is numerical numbers. So, but they have 1 in number. So the cardinality of E intersection B is 1. These are the things they have in common. Now, lastly, we have the intersection of the three, which is D. And this we have to be, we have 1 here, we don't have 1 here, we don't have 5. So you can see that in this case, the numerical numbers here are are not the same. The numerical here are not also the same with the numerical here. In this one, we don't have numerical numbers. In this case, we don't have numerical, but in all, we have alphabet. So let's concentrate on the alphabet. Now, there is just one alphabet there, and that is B. And here we have B, here we don't have B. But in this other one, we have A, and we don't have A. So you can see that they don't have anything. All of them do not have anything in common. All of them do not have any. There are some here, but this one doesn't contain. The one here is here, but this one doesn't contain. There are some here that are not also included. So you can say that the three intersection is 5. It's a 5. This is a null set. They don't have anything in common. So we can now plug the various elements in. Like in this case here now we have. In this case here now we have 5. In this case here now we have 5. While in this case here now we have plus 4. In this case here now we have plus 4 minus D intersection B. D intersection B we said is 0, is 5, minus D intersection E we said is 2, and then minus E intersection B we said is 1. E intersection B is 1. Then lastly, this other one we said is 5. So bringing them together, 5 plus 4 plus this will give you 13. 5 plus 4 will give you 9. 9 plus 4 will give you 13. This one is 0, so we have 13 already. Minus this one is 0. This one is 2. Minus 2. Minus 1 is also here. And plus this one is 0. Plus 0. So if you bring this together, minus this, negative 2, negative 1 will give you 13 minus 3 plus 0. That one goes off. So we have equal to 10. So you can see that from this expression, you can see that this also is the same with the just by counting them. So the thing I would just say is we should go and look for a formula that we may maybe use when we are considering the union of 4 or 5 more sets greater than 3. That's an assignment for the students. Now, after this, having said this, let's quickly go to the last topic that we said we are going to consider for the day, which is the intersection of two sets. Intersection of two sets. Intersection of two sets. Intersection of two sets. Now, what do we mean by the intersection? Know that we are dealing with set operation. Intersections of sets. Now, what do we mean by intersection? Already, in this case, we have been talking about it for the past days. Intersection simply means things that they have in common. Elements that, if we are maybe considering two sets, now the intersection of those two sets is the elements that are common in those sets. Now let's consider the case that we did. Let's consider D, where we have each element to be 1, 5, 7, A, and C. And let's say we have B again, where B, the elements thereof are 2, 4, 6, and B. Now, let's say the last one, E, where its elements are A, B, C, and D. Now, in this case, the intersection. Now, intersection, we can also denote it as this. These we have been writing, like in the earlier stage of this class, we have also denoted it. But this is the symbol we use in denoting the inverted U, or a bigger N. This is what we use in denoting intersection. So if we are interested in the intersection of two sets, we are saying we write it as D intersection B, and this is also a new set, a collection of new elements. Now we're saying that the elements that are common to both D and B. And what are they? If you look at this, they don't have anything in common. D intersection B is a null set. They don't have anything in common. They don't have, either you write it like this, or you say you just leave this thing like empty, like that. It's a null set. Now let's consider D intersection E. D intersection E. D intersection E, do they have anything in common? Yes, they have A here, they have B here. So it's a new set called this and this. That was why in terms of the cardinality we said it's 2. Now, lastly, we can also determine B intersection E. And B intersection E is, do they have anything in common? If you look at it, yes, B, there is one, all these are numerical numbers, whereas this one is an alphabet. We have a here, I mean a B here, B. So B intersection E is a set where we have just one element. So in other words, we are saying that the intersection of two elements is a collection of elements that are common to both. Now we can also go ahead determining the intersection of 3 elements. Say D intersection B intersection E. And this is also a new set. It's also a new collection. Where we have, do they have anything in common? If you look at them in this case, you can see that they don't have anything in common. Because this we have considered previously. And you can see that in this case it's a 5 set. There is C here, there is here, there is A here, there is A here. But there is no A and C in this one. So all of them, they don't have anything in common. There is B here, there is B here, but there is no B here. So they don't have anything in common. So either you write it like this, or you just leave it open. So it's a 5, it's a null set. So you can, as we did in the case of the union, we can also do the same to that of the intersection, where we can deal with more than one or 2 or 3 sets, considering either their union or their intersection. So with this, I am pleased to conclude that all these are very important as far as mathematics is concerned. For the union, it's just a collection, a combination of the elements from the various sets, whereas that of the intersection, we are talking about elements that are a collection of just elements that are common to the various elements that are interquestions. Now, I also wish to conclude by saying, don't just watch these videos and go away. Try as much as you can to subscribe so that whenever we upload, you will have a notification that a new clip has been uploaded. So please try and just click on the subscription button. Thank you as you do that.